Hello and welcome our webinar, which is broadcast every Thursday at 11 a.m. It is very important that the fire detection and alarm systems are correctly designed in order to be installed in accordance with their purpose and to keep them in continuous operation. While projecting and designing, current regulations and standards should be taken into account by experts and competent people. The design should be completed by choosing appropriate protection products according to the purpose of use of the building. EN 5414 Planning, Design, Installation, Commissioning, Use and Maintenance Manual is published by the European Standardization Committee TC 72 Technical Committee in order to gather the related designs under a certain standard. This standard has changed in 2004, 2008 and 2018. EN 5414 standard includes guidance for planning, design, installation, commissioning, use and maintenance of fire detection and alarm systems so that they can be correctly projected and kept in continuous operation. In the current version, as stated in the article, the detection radius of the optical smoke detectors is determined as 6.2 meter, and when the detector is placed for a square detector array in an open area, the distance of the optical smoke detector to a wall or a large obstacle can be 4.4 meter at most. The distance between the two smoke detectors. It is projected to be maximum of 8.8 meter. In such a settlement, the detection area of an optical smoke detector is approximately 77 meters square. 6.5.2.2 is a requirement about smoke detectors. The maximum detection radius for a smoke detector is 6.2 meter. For a square detector array in an open area, the detectors may be no more than 8.8 meter from each other and no more than 4.4 meter for a wall or large obstacle. In corridors not exceeding 2 meter wide, only points close to the center line of the corridor should be considered, and accordingly, if smoke detectors are placed at 12.4 meter intervals, the distance to the wall should be a maximum of 6.2 meter. If the projected area has a slope ceiling, for detectors at or near the top, the horizontal distance given above may be increased by 1% for each degree of slope, up to a maximum of 25%. In the current version 6.5.2.1 of the standard, the detection radius of the temperature detectors is determined as 4.5 meter. And when placing the detector for a square detector array in an open area, the distance of the temperature detector to a wall or a large obstacle can be maximum 3.2 meter. The distance between the two temperature detector is maximum 6, projected to be 4 meter. The detection area of temperature detector in such a settlement is approximately 40 meters square. 6.5.2.1 is a requirement about heat detectors. The maximum detection radius for a heat detector is 4.5 meter. For a square detector array in an open area, the detectors may be within 6.4 meter of each other and no more than 3.2 meter from a wall or large obstacle. In corridors not exceeding 2 meter wide, attention should be paid only to the points close to the center line of the corridor, and if the heat detectors are placed at 9-meter intervals, the distance to the wall should be a maximum of 4.5 meter. If the projected area has a slope ceiling, for detectors at or near the top, the horizontal distance given above may be increased by 1% for each degree of slope up to a maximum of 25%. Six point five point two point two is about smoke detectors. In corridors not exceeding 2 meter wide, only points close to the center line of the corridor should be considered, and accordingly, if smoke detectors are placed at 12.4 meter intervals, the distance to the wall should be maximum of 6.2 meter. If the projected area has a slope ceiling, for detectors at or near the top, the horizontal distance given above may be increased by 1% for each degree of slope, up to a maximum of 25%. Six point five point two point one is about heat detectors. In corridors not exceeding 2 meter wide, attention should be paid only to the points close to the center line of the corridor. And if heat detectors are placed at 9-meter intervals, the distance to the wall should be maximum of 4.5 meter. If the projected area has a slope ceiling, for detectors at or near the top, the horizontal distance given above may increase by 1%, as I said, for each degree of slope up to a maximum of 25%. With the amendment, as stated in paragraph F of the general article 6.5.1, says that if the length of the sailing irregularity, for example a beam, is less than 10% of the sailing height, sailings should be machined as if they were flat, and radius limits of 6.5.2 should be applied. And again, with the amendment of the 6.5.1, general article in the article F says that if the length of the sailing irregularity, let's say again beam, is less than 10% of the sailing height, sailings should be machined as if they were flat, and radius limits of 6.5.2 should be applied. Six point five point one is the general requirement about the sailing irregularities effect on detector mounting. Sailing irregularities, if the length of the sailing irregularity, for example beam, is more than 10% of the sailing height, this irregularity should be considered as a wall. In this case, the following conditions will apply. As you see on the screen, if capital D is greater than 0.25 multiplied by capital H minus lowercase h, detector in each cell. And the same calculation, if the same calculation is less than capital D, detector in every second cell. And 0.13 multiplied by capital H minus lowercase h is less than capital D. In this situation, we are using one detector per 3 cells. What is capital D in this figure? D is the distance between the beams, and its unit is meter, measured from outside to outside. Capital H is the sailing height. Its unit is meter. Lowercase h is the depth of the beam, and its unit is meter. After the change 6.5.1 general, on the statement B, flat slope sailings if the protected area has a pitch roof. Detectors should be placed at each vertex. If the height difference between the bottom of the sloping ceiling and the top of the hill is less than 6 cm, the roof is treated as flat if smoke detectors are used. If the difference between the highest point and the lower point of the sloping ceiling is greater than 60 cm, the ceiling is considered to be inclined, and the detectors are installed by increasing the radius values by 1% for each degree of sloping. Of ceiling slope, Radius values can be increased up to a maximum of 25%. As you see in the screen, flat ceiling and inclined ceiling. Detector installation in suspended ceilings. The criteria for using detectors in suspended ceilings are 6.5.1 of the standard. It has been determined in paragraph G under the general heading. What is paragraph G? Detection in gaps above suspended ceilings. If there is a risk of fire on the suspended ceilings, fire detectors, at least one each independent place, should be mounted on the suspended ceilings. In cases where the cables in the suspended ceiling are fire resistant, if the flammability of the cables at any point exceeds 25 mJ, a detector is used in the suspended ceiling. In cases where the cables are not fire resistant, in the flammability amount exceeds 15 mJ, a detector is used in suspended ceilings. The criteria for detector installation in raised floors are of the standard 5.3.9. Areas that do not need to be protected are specified under the item. 5.3.9 Areas that do not need to be protected. Statement F. Gaps, including underfloor and overhead cavities, need to be protected with detectors only if there is a likely to be a widespread of fire or smoke outside relevant space before the fire is detected by detectors outside the space. And if a fire in a cavity is likely to damage the emergency system wiring before the fire is detected. While installing the detector under the floor, the settlements in the figure can be taken into account and accurate project and application can be achieved. Sampling device from the ventilation duct is used when detecting in ventilation ducts. This device has an optical smoke detector and a pipe to be placed inside the duct. A part of the air in duct is delivered to the device and the smoke detectors inside through the pipe, and the detection is made in this way. The criteria for installing detectors in ventilation ducts are of the standard 6.5.1 is stated in the clause E under the item General. 6.5.1 General detectors for air ducts. Air duct smoke detectors must comply with EN 5427. To avoid the effects of air turbulence, smoke detectors or probes should be installed in straight duct extension, nearest vent, corner, or at a distance of up to a 3 times width of the joint. In the new version of the standard, when installing the detector at a point where there is a air movement, there has been a change in the distance to be considered. According to this, statement D is about ventilation and air movement. Point detectors should not be installed within 0.5 meter of any high velocity where the air velocity is greater than 0.5 meter per second. Another factor affecting the detector placement is our walls, partitions, and obstructions that may be near the detectors. Information on this subject is 6.5.1 General Clause of the Standard is quoted in Clause C. 6.5.1 General, the statement C about walls, partitions, and barriers. Detectors, except optical beam smoke detectors, should not be mounted within 50 cm of any wall or partition. If the room is narrower than 1 meter, the detector can be applied to the center of the room or should be installed close to its center. Where rooms are divided into sections by walls, partitions, or shelves that extend up to 30 cm to the ceiling, the sections should be considered as reaching the ceiling, and each section should be considered as a separate room. A gap of at least 50 cm should be left in all directions around each detector. The identification clause that comes with the new version of the standard is when an alarm comes, it aims to quickly and easily find the point where the alarm came from, which will be seen on the panel screen. 6.5.5 Identification. The control and identification equipment may have the ability to individually recognize the detector or alarm button that the alarm is given. In this case, a method should be provided to ensure that the indicator of the control and indicating equipment is associated with the relevant detector. If the detector tags are used to provide the necessary cross-relationship between detectors and alarm buttons and control and indicating equipment panel, which is identification numbers or letters must be added. Flame detector classes. The table shows how many square meters of area class one flame detectors protect depending on installation height and viewing angle. And this is for class 2. And this one for class 3. Beam type smoke detectors. In the current version of the standard, a change has occurred in the detection radius of the beam detectors. Information on the placement of the beam detector is specified in 15.4 complied in high sailing areas. The detection radius of a beam detector is 6.2 meters. When we make a layout as in this figure, the detector maintains an area of 12.4 meters horizontally. When the transceiver is placed at a distance of up to 100 meters from each other, the area protected by a beam detector is approximately 1,240 meters square. When placing the beam detectors, it is necessary to install them so that they remain within the upper 10% of the room height. 15.4 Areas with high ceilings, linear beam detectors should be mounted at a sufficient height, 9 to 12 recommended. The distance of the IRE beams of the beam type smoke detectors to a wall or any obstacle is minimum 50 cm. Active air sampling detectors used in places such as system room, archive museum, library, cold storage. It works with the principle of taking the air in the room with the sampling pipes on the top and controlling the presence of smoke particles in the air by passing this taken air through the filter. When designing active air sampling detectors, a maximum of 4 pipes can be used in the system, and the total length of these 4 pipes can be maximum of 200 meters. The length of any pipe in the system it can be up to 100 meters. Information about the detection distance of the holes on the pipes is also given in the article 6.5.2.2 of the standard. And what about 6.5.2.2 smoke detector standard? For aspirating smoke detectors, the sampling openings are considered to be equivalent to a point detector. The Stratos HSSD2 is designed to provide highly sensitive smoke detection in large spaces. Class fire detection artificial intelligence ensures that the detector operates with optimum sensitivity for the protected environment, without the need for complex setup. Thanks to its artificial intelligence feature, the product can self-configure to provide high sensitivity in computer room or reduce sensitivity in a smoky area. It can be integrated into any fire alarm systems via its dry contact de-energized outputs. The coverage area can be up to 2000 meters square. It offers high sensitivity to laser-based and advanced light scattering for reliable early warning. It complies with EN 5420 standard patented dual technology, LDD 3D laser dust separation and elimination system is available. It provides RS485 communication as standard for network and remote communication, and it is LPCB certified. This is the structure of our device. Air sampling smoke detectors. Stratos Micra 25, Stratos Micra 100, Stratos HSSD 2. Cable type temperature detectors, which are one of the most preferred products in areas where projecting conditions and maintenance are difficult, such as cable galleries, highway and railway tunnels, consist of sensors placed in a spatial cable at a regular interval and detect any fire that may occur through these sensors on it. The sensors can be individually programmed according to both the amount of the temperature rise, predetermined temperature alarm threshold levels. A maximum of 250 meters of SEC15 cable is connected to the right and left of the SCU 800 control unit, which is the sensing unit of the product, and each of these 250-meter cable contains 99 sensors that detect temperature. These sensors are sensitive enough to detect a change of 0.1 degree. With the help of the Modbus integration, we have developed the control unit of the linear cable type temperature detector makes Modbus communication with the intelligent addressable fire alarm panels over the RS-232 protocol. In this way, we can instantly display the temperature values of the sensors on the cable type temperature detector over the smart addressable fire alarm panel. All linear cable type temperature detectors in the cable are detected as input devices in the panel. After the standard has been updated, information on the criteria for projecting the alarm buttons has been given in the 6.5.4 alarm buttons article of the standard. 6.5.4 alarm buttons should be placed on escape routes, all doors opening to inside and outside of escape stairs, and all exits to open air. They can also be placed near special hazards and firefighting equipment. In cases where there are people with limited mobility, inadequate or special care needs, such as nursing homes, hospitals, intensive care units, extra care may be required for the placement of alarm buttons. Alarm buttons should be clearly visible, identifiable, and easily accessible. In general, alarm buttons should be fixed at a height of 0.9 meter to 1.4 meter from the floor. 1.2 meter is preferred and comply with EN 5411. After the change of 6.6.2 audible alarms, the sound level provided should be such that the fire alarm signal can be heard just above any ambient noise, but the sound level should not be above 118 decibel at any point where the people may be present. The fire sound must continue for more than 30 seconds, at least 65 decibel or 10 decibel above any noise, whichever is greater. It was in shape. Another point to be considered while placing the sounder is settlement to be made in the places where there are sleeping people. 6.6.2 audible alarms requirement says that if the fire alarm is desired to warn people sleeping, the minimum sound level at the head of the bed should be 75 decibel. Another important issue is the doors when placing the sounders. If there is a door or a fire door in the projected area, there will be a loss in the sound to be heard from the siren. This loss to occur is 20 decibel for normal doors and 30 decibel for fire doors. If there are fire compartments separated by a fire door in the project, there must be at least one audible warning device in each fire compartment. If the placement height of the audible and light warning devices should be installed at a height of at least 2.1 meters from the ground, and wiring should be projected. In areas that are likely to be used only by the hearing impaired, procedures should be in place to inform them of the alarm, and all visual tactile alarm devices should be used to supplement audible alarms. While placing the visual alarm devices, factors should as ambient light, whether the visual alarm device will be mounted on the ceiling or the wall may affect the placement of the visual alarm device. As you see on the screen, there is installation of visual alarm devices on the ceiling figure, and there is wall mounting of visual alarm devices. Example, it is accepted that the environment in which the wall-mounted flasher is used, which has EN 5423 approval. W242 declaration light intensity of 350 lux and the imagining methods in indirect. In this case, the table is returns the 1.2 multiplication factor. Scope of visual alarm device values with 2 meter each side multiplied by 1.2 give the result 2.4 meter. The 2.4 meter mounting height is also multiplied by 1.2 to get 2.88. Visual alarm device can be used in W 2.88 to 2.4 position. After the change, the scope of detection zone was increased. Accordingly, the largest area should be projected with a maximum floor area to 2000 meters square. In the conventional system, the floor area of the largest zone should not exceed 2000 meters square as a detection zone. After the change in areas containing more than one fire compartment, the project should be designed in such a way that the boundaries of the zone are borders of the fire compartment, and the floor area of each zone should be maximum of 300 meters square. After the change, in case of a single short circuit or open circuit cable fault, while performing the circuit design, must ensure that no more than 32 detectors or 10 alarm buttons are disabled in the detection zone. Short circuit protection can be provided by selecting the fire alarm buttons located at the boundaries of the detection zone in the model with isolators. The wiring of audible or visual warning devices must be done in such a way as to ensure that at least one audible or visual warning device remains operational in case of any short circuit or open circuit fault in the system. As you see on the screen, the wiring of audible or visual warning devices must be done in such a way as to ensure that at least one audible or visual warning devices remains operation in case of any short circuit or open circuit fault in the system. While placing the panels, if it is not to be placed as an operator panel, the screen and indicators of the panel must be at least 89 cm above ground level. If there will be no placement as an operator panel, the height of the screen and indicators should be at least 1.4 meter and at most 1.8 meter. 6.8.3 Standby power supply. Statement B, in conditions where it is not followed continuously or error signals are not forwarded to a call center instantly, it should give 72 hours of fault warning, 30 minutes of fire alarm. Thank you for listening and thank you for your participation. If you have any question, please do not hesitate to ask us by using email address on the screen.